So we're going to look at central angles and inscribed angles in a circle. So a few quick vocabulary terms. A chord, so if you have a segment or a circle, and within that circle you have a segment whose endpoints are on the circle, like that. It's just a line that goes from one side of the circle to the other. That's called a chord. Central angle, so if you know where the center of the circle is, you can put an angle there from the center, and that is a central angle. The vertex is the center of the circle. An inscribed angle, it's basically just two chords puts the vertex on the edge of the circle. That's an inscribed angle. And then an arc is just a portion of the circle. Like that part I just highlighted there in red, that's an arc. It's part of the circle. So a pretty simple postulate. We've done these with angles and segments. If you take arc AD and arc DB, AD plus DB, it equals the entire arc from A to B, ADB. So if you add up the two smaller pieces, it equals all of them. That's all I'm saying. So there are, within arcs, we can talk about minor arcs or major arcs. A minor arc is less than half a circle. So the measure of a minor arc is equal to the measure of the central angle. It's less than half the circle. That's the minor arc. It's the short way from point A to point B. It's the short way. A major arc is more than half a circle. If you're trying to get from A to B, it's like going the long way. You have to go around from A through D to get to B. When you name a minor arc, you use 2 points. When you name a major arc, you use 3 points. We have minor arc and major arc. If you put them together, it has to equal 360. That's where that equation comes from. Just together, it's a whole circle, 360 degrees. And then a semicircle is half a circle. The endpoints are the diameter. Typically, you use 3 points when you're naming a semicircle also, so you know which half of the circle you're talking about. Because you can go from A to B around the left, so that would be counterclockwise by going through D. If there's a point over here, you can go clockwise from A to B, and that would be a different semicircle. Kind of skipped over it, but you just put the little arc symbol above the 2 points or the 2 letters to name the arc, or above the 3 letters if it's a major arc. So, measure of angle BCD is 18 degrees. Let me go back to this for a second. The measure of an arc is equal to the central angle. So whatever this angle is in the middle, that's the measure of that arc. The measure of a minor arc is equal to the central angle. So since this central angle right here is 18 degrees, that means this arc is also 18 degrees. We're also told that arc EF is 33 degrees. We're trying to find the measure of arc ABD. So to find the measure of arc ABD, we already know what BD is. We just need the first part of it, AB. We got to tie in some prior knowledge here. These are vertical angles. So if the arc is 33, the angle is 33, which means the other angle is 33, which means the other arc is 33. So AB is 33 degrees, BD is 18 degrees. Add those to get the measure of arc ABD. Here they use 3 letters for a minor arc. That's okay. It's just for clarification. You add those together and you get 41, 51 degrees. Here's another one. JK is 27 degrees. NP is what we're trying to find. So NP is on this smaller circle, but it doesn't matter. That arc will have the same measure as the big arc if that's what we're looking for. So if this is 27 degrees here, the central angle will be 27, this arc is 27, everything around here is 27 degrees, so that's 27 degrees over there. We also know that this angle, PCK, is 90 degrees, which means we also have 90 degrees up here. So this entire arc must also be 90 degrees because it's a 90-degree central angle. We do 90 minus 27, we get 63. So this arc right here is 63 degrees. So the measure of arc NP is the same as that larger arc out there. 63 degrees. So the central angle and any arcs that are formed by that central angle are all going to have the same measure. EF is 45 degrees. ACD is 56 degrees. Now EF, you've got a vertical angle right here with just the portion right there. So that's also 45 degrees. But the whole thing we said is 56. We're trying to find BD. So 45 plus whatever BD is equals 56. So we can subtract. We get that this part must be 11 degrees. So the measure of arc BD is 11 degrees. There's another relationship, an inscribed angle. We said central angles were the same as the arc. Inscribed angles are half the arc. Central angles are equal to the arc. Inscribed angles are half the arc. And an inscribed angle is just when you have two arcs or two chords that form an angle. So we have a lot to determine here. First, we have this arc is 18 degrees, and then we have this angle down here, which is an inscribed angle, is going to be half the arc. So the measure of angle BAE will be 9 degrees. Don't think it actually asks for that, though. Here we have an inscribed angle, 54 degrees. The angle is half the arc. So if that's 54, the arc would be double 108. Arc DE, yep, measure of arc DE is 108 degrees. So the measure of arc BD, going all the way around, would be the 18 plus 108. 18 plus 108 is 126. Measure of angle DAB, DAB. We said this was 9 degrees here. So DAB, you'd have to add those two together to get that entire angle. 54 plus 9, 63. And then ADE, this angle. So that is an inscribed angle. It's two chords, vertex is on the circle, so it's going to be half the arc. So look at the arc. AE, that's the diameter. This means ABE, this arc right here, is a semicircle, so that's 180. Which means that the angle is half of it, because the inscribed angle is half the arc. Half of 180 is 90 degrees. Similar problem here. WX, XZ. So here we have an inscribed angle is 9 degrees, which means the arc is double. So the measure of arc WX, we just said is double, 2 times 9, 18 degrees. We also can see here that WZ goes through the center, that's a diameter, so this whole thing going around from W around to Z is 180. So 180 minus that 18 162. So from X to Z, is 162 degrees. And then you get some angles, XWZ, XWZ. That is an inscribed angle. So it's going to be half, that arc right there, half of 162. Half of 162 is 81. And the last part, WXZ, WXZ. It intersects a circle there and there, which is a semicircle, 180 degrees. So the inscribed angle is half of that. Half of 180 is 90. EDF is 15 degrees. EDF is 15. So that means the arc F to E is 2 times that, so 30. We're trying to find the measure of ABE. So we do know that this arc up here is 44 degrees. So the angle is 22. We also know that this arc right here, FE, is 30. So any inscribed angle is going to be half of 30. We have another inscribed angle right there. So that's going to be half of 30, so that's 15. So if we're trying to find ABE, so that whole angle right there, we need to add those together, 22 plus 15. 37 degrees.